Number 26, simplify the complex number 1 minus 2i to the power of 5. One of the ways to do that is to use properties of exponents and break these powers into something that is a little more palatable, squares and powers of 1. So that's what we have here, to the complex number squared times complex number squared times complex number to the power of 1. Just FOIL it out. Note, anytime we have an I times I, that's I squared, and I squared is -1. So simplifying all the way down, it produces the complex number 41 plus 38i. However, a second way that we could have done this is using our friend Pascal's triangle. And maybe it's simple, maybe it is just another way, and it's good for us to practice our mathematics gymnastics. But if there is a power of 5 on a binomial or a complex number, we use this row of Pascal's triangle to produce our coefficients. So Pascal's triangle, you add these two numbers to get the next number down, and you do this along the way. Reasons, math reasons. So I'm going to use those as the coefficients of a product of these two components of a binomial, of a complex number, of things that are, it's this product of two, binomial decomposition. So 1 and then -2i, and those are going to show up every time we have a coefficient given to us by Pascal's triangle. However, the power is going to start at 5 for the 1 and start at 0 for the -2i, and then we're going to subtract 1, add 1 at every stage. Subtract 1, add 1. Subtract 1, add 1, to the exponents, mind you. Because that's what happens in the distribution process if we expand this binomial all the way out, like happened here, or how it would be done through a process of multiplying and FOILing and combining like terms. The exponent on the first term, that 1 is going to be multiplied out 5 times, and the -2i is going to be multiplied to the 1 none times. But then it'll be multiplied together. There'll be 4 of these and 1 of these multiplied out a set number of times, happens 5 times, and so on and so on. Now we need to use properties of exponents. So a property of exponent says anything to the power of 0 is 1. And of course, 1 raised to the power of a positive exponent, that is also 1. So this term right here is essentially a 1. Likewise, 1 to the power of 4 is just a 1. And anything to the power of 1 gets to be back to itself. So -2i.